What's going on, everybody, and welcome back to High Peak Education. I would like to perform a calculation here regarding solenoids and inductance. So let's look at this problem. Consider a uniformly wound solenoid having n turns in length L. Calculate the inductance of a solenoid with 300 turns. Its length is 25.0 centimeters and its cross-sectional area is 4.00 centimeters squared. B. What is the self-induced EMF if the current decreases at a rate of 50.0 amperes per second? Well, in part A, I think the first thing we need the inductance of the solenoid. So the inductance of the solenoid, okay, so this is the symbol for inductance, is going to be, let's see, so it's the mu naught, that's the permeability of free space, times n squared, that's the number of turns squared, times the cross-sectional area divided by the length of the solenoid. Now, in order to calculate this problem, I think we need to have everything in SI units, so let's make sure we do that. So n, we know that's 300 turns, and that's unitless. And then we also know that the length is 25 centimeters. In SI units, that's 0.250 meters. And the cross-sectional area is 4 centimeters squared. So 4.00 centimeters squared. If we want to get that in square meters, we have to go centimeters, meters. There's 100 centimeters in 1 meter, but we have to square this relationship. So I think that we get 4.00 times 10 to the minus 4th meters squared. Hopefully you see where I get that. It's 1 over 100, which is 1 over 10 squared. So there we go. And let's see. So I think that's all we need. So let's put the numbers in. Now mu naught we know is 4 pi times 10 to the minus 7th Tesla meters per ampere. That's the constant. The permeability of free space. N squared is 300 squared. The cross-sectional areas that we just calculated, 4.00 times 10 to the minus 4 meters squared. And we divide that all by, the length, which is 0.250 meters. Okay, let's use the calculator to aid us. Okay, let's try this calculation. Alpha F1, numerator over denominator. There we go. So we should have, let's see, 4 times pi times 10 raised to the minus 7th power. And then that times 300 squared. Whoops, that should be 300. Sorry for that. Second insert, 300. There we go. There we go. Okay. And then times 4 times 10 to the minus 4. 4 times 10 to the second EE minus 4 power. And we divide that all by 0.25. So this should be 1.81 times 10 to the minus 4. So let's write this down. L of the solenoid is 1.81 times 10 to the minus 4, and that's going to be henries. Now, by the way, one thing to note, this would be 0.181 millihenries. Now, by the way, millihenries is the most typical range to find inductance for almost all inductors. Millihenries is sort of the most typical, just sort of way they're expressed, even though henries is the SI unit. All right, let's look at B. B, we want to know what is the self-induced EMF if the current decreases at a rate of 50.0 amperes per second. Well, the EMF from the self-inductance from the inductor should be minus L di dt. And I think we were just given what di dt was. It's 50 amperes per second. So we can just plug right in. And this right here is from the solenoid. So we can do minus 1.81 times 10 to the minus 4 henries. And that multiplied by 50.0 amperes per second. Alright, so let's go ahead and get this value. Oh, and by the way, this current is decreasing in time, so it's a minus. But minus times minus would be plus. So it's going to be a positive EMF that's in the opposite direction of how the current's flowing. So anyway, that's the idea. So the calculation should be 1.81 times 10 to the minus 4 power, and that times 50. Now, by the way, minus times minus is just a plus, so we'll just ignore that. So that's 0.00905. So this is 9.05 times 10 to the minus 3. That's volts. So this is in the millivolt range. So that's 9.05 millivolts. Okay, so it's not extremely large. Okay, this is kind of a smallish solenoid, but you get the idea to how to do this calculation. So thank you very much for your attention. Thanks for watching High Peak Education. Please smash that like button if you enjoy this content. Please subscribe to the channel and share this video amongst your social network. And I will see you in the next video.